Hello everyone, welcome back. Let's talk about another easy problem on Leetcode today. Valid palindrome, Leetcode 125. This problem is part of Blind 75, a curated list of essential coding interview questions. You can find the full list linked in the description below. Be sure to check it out. Now to the problem. In this problem, we are given a string s and we should return true if it is a palindrome or false otherwise. Here the string is a palindrome if it reads same forward and backward after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters. Then in example 1, for the given string, after removing all alphanumeric characters, that is characters that are not letters or digits like this space or comma or colon or other punctuation marks, and then converting it to lowercase, we will get the string like this one. And if we read it forward or backward, it will read the same. Hence, it's a palindrome. So, we will return true in this case. Then in example 2, race a car is not a palindrome because after removing non-alphanumeric characters and converting to lowercase, the resulting string would be this one. And here the first half does not match the second half when read in reverse. So, we return false. However, the string race space car is a valid palindrome because after pre-processing it, it becomes race car, which reads the same forward and backward. And finally, in example 3, we are given a string containing only spaces, and when we remove all non-alphanumeric characters, we will get an empty string. And since an empty string reads the same forward and backward, it is a palindrome. We have already solved the problem of checking if a string is palindrome or not, where we verify that characters in the string match when we read them from the front and back. If you haven't seen that video yet, please check out the description or the I button for better context. Here, we have a variation of this problem with two main changes. First, we must ignore non-alphanumeric characters. So, here we focus only on letters, which are alphabets from A to Z, both in small and capital case, and digits from 0 to 9, effectively skipping anything else like spaces, punctuations, etc. And second difference is case insensitivity. As in this problem, case differences shouldn't matter, meaning, for example, capital A is equivalent to small a, and the solution can range from few lines to a more detailed implementation, depending on how the interviewer wants us to solve the problem. So one approach is to pre-process the string by removing extra characters and converting it to a lowercase. This ensures that we only focus on alphanumeric characters. For example, after this pre-processing step, this sentence string becomes like this one. And to remove non-alphanumeric characters, one common option is to use regex, where we can use a pattern like this one, which matches all non-alphanumeric characters, and replace these characters with an empty string, where this caret within brackets means not, and A to Z in lowercase and uppercase specifies all letters, and 0 to 9 specifies all digits. So, this regex matches any character that is not a letter or digit, that is all non-alphanumeric characters, and we should remove these characters by replacing them with an empty string to get a clean string, which we can convert to lowercase. Alternatively, we can manually iterate through each character of the string and check if it is alphanumeric. In Python, for example, we can use isAlphanumeric function, and in Java, we can use isLetter or digit function, which tells us whether the character is alphanumeric or not. And if that is the case, we build a new string by appending that valid character. This ensures we skip spaces, punctuations, and other non-alphanumeric characters. And once we have this clean string, we can check if it is palindrome or not by reversing the string and comparing the two strings. In Java, we can reverse a string by creating a string builder from the clean string and then calling its reverse method. In Python, we can use string slicing, which has following syntax, where we create a new sequence from the original sequence or string, starting from start index, which is inclusive, and ending at end index, which is exclusive, taking given step at a time. Here, for example, start and end indices are omitted. So that means we start from the very beginning of the string to the very end of it. And step is -1, meaning we should traverse the sequence backwards, one step at a time. So this creates a new sequence that is a reverse of the original. If they match, the string is a palindrome. Otherwise, it is not. Another way can be we just iterate to the middle and compare each character from the start with the character at the corresponding position from the end, and stop as soon as we find a mismatch and conclude that string is not a palindrome. However, if the loop completes without finding any mismatches, the string is a palindrome. And the final approach can be we can also use a two-pointer approach, which we used in the previous solution for checking the string if it is a palindrome, where we place 2 pointers left and right at both ends of the strings and compare the characters at both pointers. If they match, we move the pointers inwards. And if we find a mismatch at any point, we conclude that the string is not a palindrome and return false. Otherwise, if the pointers meet or cross each other without any mismatches, the string is a palindrome and hence we will return true. Now the time complexity of all the approaches we discuss is O of n, where n is the length of the string. This includes preprocessing the string to remove non-alphanumeric characters and checking whether it's a palindrome, either by reversing the string or looping through it to the middle, or using the two pointers technique. Both steps, preprocessing and palindrome checking, take O of n time. So the overall time complexity is O of n. However, all of these solutions require us to preprocess and create a new transformed string after removing all the alphanumeric characters and converting it to lowercase, which results in a space complexity of O of n since we store the transformed string. And sometimes the interviewer might ask to solve the problem without applying any preprocessing or allocating additional space. In this case, we can still use two-pointer approach to solve this problem directly without the need to transform the string, ensuring O1 space complexity, much like we did in the previous problem. So we place 2 pointers, left pointer, which starts at the beginning of the string, and right pointer, which starts at the end of the string. Now we will start moving the 2 pointers inwards until both the pointers meet. First character the left pointer sees is underscore, which is not a letter or number. And I have taken underscores in the example here for the visibility, but it can be any non-alphanumeric character like spaces, colon, etc. But the main point is, when we encounter a non-alphanumeric character, it doesn't make sense to compare it with the character at the right pointer and vice versa. Instead, we skip this character and move the left pointer forward in search of a letter or digit, and the next character we see is underscore again. So we skip it forward as well. And now the left pointer points to character T, which is a valid letter, and the right pointer points to lowercase t, which is already a valid alphanumeric character. So the right pointer doesn't need to skip inwards. And now, since both the left and right pointers point to valid characters, we can perform the first comparison. And ignoring the case difference, the capital T matches the lowercase t. So we can move both pointers inward to perform the next comparison. And now both the pointers point to character A, which is again a match. So we again move the left and right pointers inwards. Now the left pointer points to lowercase c and right points to uppercase c. And ignoring cases, both the pointer values will match. So we again move both the pointers inward. Now the left pointer points to underscore, which is not a valid character. So it will skip it forward and move to character O. Similarly, the right pointer skip its underscore as well and points to character O as well. And now, since both the left and right pointers have met, we can end the loop immediately. This indicates that all the characters in the left half and the right half in reverse order match. For odd length palindromes like this one, there will be one character remaining at the center, which doesn't need any further validation, since both the pointers now point to this character. And for even length palindrome, the pointers simply cross each other after validating all pairs, confirming that there are no mismatches. So when writing the code for this approach, we can skip the equality check and simply run the loop until the left pointer is less than the right pointer. However, if a check for equality is included, that should still work fine as it won't affect the overall correctness. So in this example, as we couldn't find any mismatch, Taco cat is a palindrome and hence we will return true. However, if the string was taco rat, following the same process, there would have been a mismatch when left pointer would have pointed to small case c and right would have pointed to capital R. And as there was a mismatch, we will return false in this case, indicating taco rat is not a palindrome. Now the time complexity of this approach is O of n, since we are processing each character of the string only once, and the space complexity will be O of 1 because we are doing the comparison in place without using any additional data structures. Here is a quick code walkthrough of the algorithm we just talked about, with Java code on left and Python on right. First, let's initialize two pointers, left pointer starting at the beginning of the string and right pointer starting at the end of the string. Now, we will run the loop as long as left pointer is less than the right pointer. This ensures we compare characters only until the pointers meet or cross. Now, we will skip non-alphanumeric characters at the left pointer. So, as long as L is less than R and the character at the left pointer is not an alphanumeric character, we will move the left pointer forward. We can check if the character is alphanumeric using isLetterOrDigit function in Java and isAlnum function in Python. We will repeat the similar process for the right pointer as well. Now, since both left and right pointers point to alphanumeric characters, we can perform the comparison of characters at those pointers, ignoring cases. So for that, we will convert both characters to lowercase before comparing them to ensure case insensitivity. And if the characters are not equal, it means string is not a palindrome. So we can immediately return false. Otherwise, we move pointers inward, that is, increment the left pointer and decrement the right pointer. And in the end, if the loop completes without finding a mismatch, this indicates that the string is a palindrome. So we will return true. Now, sometimes interviewer may specify restrictions on built-in methods like isLetterOrDigit and to lowercase in Java or isAlnum and lower in Python. For these situations, we can also write our own user-defined functions to achieve the required behavior. First, let's look at the function isLetterOrDigit in Java or the equivalent function isAlnum in Python. To check if the character is alphanumeric, we just need to check character's ASCII value falls into one of the three ranges. For digits between 0 and 9, it is 48 to 57. For lowercase letters, it is 97 to 122. And for uppercase letters, it is 65 to 90. But we don't need to know the actual ASCII values. Instead, we can rely on character constants for that, as when performing the comparison, the programming languages directly compare the integer ASCII values for those comparisons. So here we can just check if the character lies within any of the three ranges. If yes, it is alphanumeric. Otherwise, it is not alphanumeric. Now let's look at the function toLowerCase in Java or lower in Python. Here we can see that uppercase characters correspond to ASCII values 65 to 90, and adding 32 to uppercase character converts it to the lowercase character. So if the character is not an uppercase letter, we simply return it as is. However, if the character is uppercase, then we will add 32 to it and return the new character. In Java, we get the character and add 32 to it, which gets the ASCII value of the character C directly and adds 32 to it, and then we cast it back to character. In Python, we use ORD or ordinal function to get the ASCII value of the character and then add 32 to it and convert it back to character using chr function. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.